Test of hypothesis. What is a hypothesis? A hypothesis is an educated guess. It is a claim or statement about the population parameter. It is a conjecture or a proposition about a solution to the problem, a tentative relationship between two or more variables, or the status of a situation based on the available facts or information that the researcher already knows. Take note of the second sentence. It is a claim or statement about the population parameter. Usually in research, we have this hypothesis related to your statement of the problem because it is the main claim, or it will be the main claim that you must answer in your research. So for example, the research problem is there a relationship between achievement in mathematics and interest in mathematics of students in secondary school? So the problem here is the researcher wants to determine whether there is a relationship between these two variables, the achievement in mathematics and interest in mathematics. So the hypothesis might be there is no significant relationship between these two variables. So that is the first claim, that there is no significant relationship. Or another claim might be there is a significant relationship between the two variables, or there is a positive relationship between achievement in mathematics and interest in mathematics of students in secondary school. So these three can be a hypothesis of your research. So these three are statements or claims. Now, what is hypothesis testing? Now, hypothesis testing is a decision-making process of evaluating claims about a population based on the characteristic of a sample from the population. Now, take note that it is very difficult for a certain researcher to get the information from the whole population. So that is why we always run to getting the sample. Now, this sample will be used, or the information from this sample will be analyzed, this one, using this hypothesis testing, and then whatever the result here in the analysis part will be also the decision or the analysis for the whole population. So I know you know what happened in our previous election. So based on the surveys, a certain individual is, or a certain politician really is always number one in rank, and it is really far from the second position in the presidential race. And of course, the result in the actual election really is reflected. Now, what is hypothesis testing? Again, it decides whether to reject or accept the null hypothesis about a population. So there are two cases here. We reject or we accept the null hypothesis. Now, before discussing the null hypothesis, let's look at these steps in hypothesis testing. Okay, so these are the steps. Now, let's start first with the first one. We must know how to formulate the null and the alternative hypothesis. Null hypothesis. It is denoted by H sub O. It makes a statement about the population, not the sample. Although in using or in analyzing the data that comes from the sample, the statement must be for the population. Okay, it's just that the data needed in this analysis came from the sample, because again, we cannot get all the data from a population, especially if your population is very large. Now, what is this null hypothesis? So this is a statement, or it states that there is no difference, no changes, nothing happened, no relationship between a parameter and a specific value, or the independent variable has no effect on the dependent variable. So take note of the red highlighted word, no. So in our language, walang kaibahan, walay kalahian. Okay? So both of the parameters or variable mentioned in a problem are the same. Okay, so examples of null hypothesis. The first one, we have there is no significant relationship between these two variables. So take note, there is no. So walang relationship, walang relasyon yung dalawang variables. Next, faculty morale is not related to the frequency of promotions. Number 3, there is no relationship between attitude towards science and achievement in mathematics. So majority of these null hypotheses always use this no word or not. So that is the first one. But of course, there are cases that it doesn't use the word no. Okay? So it depends upon the problem. You must first understand the problem. And if the problem means that there is no relationship, there is no significant difference, walay kalahian, walang kahibahan, and so on, then that is the null hypothesis. Now look at number 4. Number 4, it doesn't use the word no or not. The mathematics achievement of high ability students equals that of average ability students. So take note of the word equals. So meaning the ability of the high ability students is the same with the achievement of the average ability students. So ibig sabihin, walang kaibahan yung achievement nila, mathematics achievement nila. So meaning that that falls on the null hypothesis. And of course, number 5 and 6, we have the keyword no. So those two are also null hypothesis. Now in symbols, the null hypothesis must contain the condition of equality and must be written with the symbol. It's either equal, less than or equal, or greater than or equal. So take note of this. When actually conducting the test, we operate under the assumption that the parameter equals some specific value. Kasi nga, may ibig sabihin, walang kaibahan. They are the same. Okay? So most of the books accept equal sign in symbols for the null hypothesis. So whatever the problem is, you may always use the equal sign. Okay, but for me, in order for us to also make a correct decision for the other hypothesis that we'll be discussing later, I think it's best if you know how to interpret the problem or the statement in the problem that uses this less than or equal or greater than or equal, because this is very important. Okay, because if you always use this equal symbol, then of course the other hypothesis will be affected. So you will learn that one later. So for the mean, the null hypothesis will be stated in one of these three possible forms. So it's either we use the symbol equal, greater than or equal, or less than or equal. It depends upon the statement of the problem. Note. So we have this note. We have these some keywords. So of course I know you know how to, or what are the words that relates to this equal symbol. So for the greater than or equal, we can use the at least or minimum. And for the less than or equal, we have the at most, does not exceed, and maximum. So we have equal, greater than or equal, and less than or equal. So we have an example. Write the following in symbols. Number 1, the average lifespan of a rechargeable battery is 2 years. So we can have this as HO, or the null hypothesis. We have the average lifespan is equal to 2 years. Okay. Number 2, there is no significant difference between the average hourly rate for construction workers and the average hourly rate for the manufacturing workers. So walang kaibahan yung hourly rate nila. So ibig sabihin, equal. So, construction workers, so the same lang yung average hourly wage nila. So, construction workers and then the manufacturing workers. Number 3, the average height of a grade 11 student is at least 167 centimeter. Now, what is at least? At least is greater than or equal. So, since that there is an equal there, so this is still a null hypothesis. So, at least. So, the mean is at least 167 centimeter. And last example, on the average, college students take at most 5 years to graduate from college. So, at most, we have this, less than or equal. So, the mean on the average, so that is the mean, is less than or equal to 5 years. Okay, take note of the symbol. Now, let's go to the alternative hypothesis. This is denoted by H sub A, or some books also uses H sub 1. So let's read. It is a statement that states that there is a difference, an effect, a relationship. The independent variable has an effect. So meaning the alternative hypothesis is just the complete opposite of the null hypothesis. Okay, if in the null hypothesis states that there is no significant difference, in the alternative, the opposite for that is there is a significant difference. If in the null hypothesis there is no relationship, so in the alternative hypothesis there is a relationship. Okay, so the two are completely opposite. So it is the statement that must be true, of course, if the null hypothesis is false. And it is also a statement that is false if the null hypothesis is true. Because again, these two hypotheses are opposite to each other. Now, last bullet. It is sometimes referred to as the research hypothesis. Okay? Referred to as the research hypothesis. Because as we all know, when we do our research, we always want to make a research that has an effect, okay, that has a result that is different from the existing phenomenon or status quo. So in doing research, we always have a goal that we can have a result that has a significant difference. Okay, so say for example, if you want to have if you want to make a medicine for fever, and we also know we have the biogesic. So if you want to make a research if you want to make a medicine, then of course your goal is to make it more effective, no, more effective than than biogesic. So meaning that falls now on the alternative hypothesis, because meaning it has a difference or different effect from the existing one. So that is your goal, that is it must be more significant or more effective than biogesic. So that is an example of a research hypothesis which falls as our alternative hypothesis. So for the mean, we have these three symbols for alternative hypothesis. Now if you can still recall, for HO, the opposite for this one is H equals. For this one, of course, the opposite is less than or equal. This is for HO. And for this one, we have the greater than or equal. So these are the opposite symbols. Take note of this. So we will take the same examples. Give the alternative hypothesis. So the average lifespan of a rechargeable battery is 2 years. So this is 2 years, so equals 2 years. So for the HA, this is not 2 years. Okay? There is no significant difference. So this time, there is a significant difference. So meaning these two are not equal anymore. The construction workers and the manufacturing workers. Their average hourly rate are different. Okay. Next, the average height of grade 11 male student is at least. So the opposite for this one is less than 167, because at least is greater than or equal. Now last, on the average, the college student take at most 5 years. So at most is less than or equal. So the opposite for this one is greater than. So these are the alternative hypotheses of these 4 null hypotheses. So again, when you ask how to determine whether it is an alternative or a null hypothesis, then you must analyze first if there is a significant difference, may kaibahan ba, then of course, or may relasyon ba, then of course that is an alternative hypothesis. Then if walang kaibahan, if walang relasyon, there's no relationship, then of course that is on the null hypothesis. So for the alternative hypothesis, we have these symbols and keywords. Now let's go to the significance level. So in the past, when we are studying the Z alpha and the T alpha, we always encounter these alpha. So it is related to the degree of certainty we require in order to reject the null hypothesis in favor of the alternative hypothesis. So in short, it is a probability of rejecting a true null hypothesis. Okay, so very frequently we use these 3. So I will just add, we also have the 0.10. Okay, 0.05, 0.10, and 0.01 level of significance. Now take note of this. 0.05 level of significance implies that we are willing to commit an error of 5%. Therefore, a confidence level of 95%. So test statistic. Now test statistic is now related to the formulas that is used in computing. So it is a statistic computed. It is statistic computed. It is statistic because it came from, or the data comes from the, or come from the sample. So that is why it is a statistic. Computed from the sample data that is especially sensitive to the differences between the null hypothesis and the alternative hypothesis. So the decision to reject the null hypothesis depends on the value of the test statistic, because later we will compare the result of this computation and to another value. Then upon comparing, we can then make a decision. Okay, so again, in this test statistic part, so it involves the formulas being used so that we can have a value for, or statistic for the given problem. So a decision rule based on the value of the test statistic. So we have reject HO if the computed value of the test statistic falls in the rejection region. Okay, so we will reject the null hypothesis if the computed value of this test statistic falls in the rejection region. So to visualize this first, since we're not talking about the rejection region, so say for example we have this normal curve and we have this area here, our alpha. Say for example this is our alpha. Okay, if your computed value here falls within this area, the shaded region, we call this one as the critical region or the rejection region, by the word itself, rejection region. So we will reject HO. So meaning we will reject HO. Okay, if the computed value falls in this area. Okay, again, this shaded region is the rejection region. Okay, you may also look at this one as your alpha. Okay, so later when we do the problem solving, you will understand this more. Okay, but the point here, we will reject the null hypothesis if your test statistic falls inside the shaded region. So inside the shaded region. So we have this. So I'm sure you know this already because we've discussed when to use Z and when to use T. Of course, we will use Z if the population standard deviation is known and when n is greater than or equal to 30. And case 2, if of course the population standard deviation is unknown and our sample size is less than 30. Okay. Now, we have here the the alternative hypothesis and the region of rejection. Now, the alternative hypothesis is very important in order for us to know the region of rejection. Okay, it is very important because this will be our basis. No, the alternative hypothesis is our basis to know where is the rejection region. So we have these three cases. So these two here, this is just for Z and this is just for T. But of course, the rejection region or the concept behind these two rows are the same. Now, if your alternative hypothesis uses the less than, so alternative hypothesis is less than, it means that we have this a left-tailed test. No, the direction is on the left side. So meaning the rejection region is at the left or on the left. So this one. Okay? Because of this symbol left, less than. So it's on the left side. Now if it's greater than, okay, so if it's greater than, then of course it's also greater than. So in this illustration, it is at the right side. So greater than. So the rejection region is at the right side of the normal curve. So right-tailed. So this is left-tailed. And this is right-tailed. And last, if this is your alternative hypothesis or not equal, so meaning we'll deal with this with two tails. So pag not equal, it is two tails. So we have this and this. Since this is now two-tailed, so our alpha now will be divided into two. One to the right and one to the left. Okay, so these two, we have alpha and we have alpha because these first two, the left and the right, are one-tailed test. So isang tail lang. Pero for the not equal, the alternative hypothesis, it is two-tailed test, the left and the right. So alpha over 2. So again, alternative hypothesis will be the basis of our region of rejection. So when we say non-directional, ibig sabihin there's no direction. So we will take both sides. So two-tailed. There's no direction. So of course, since there are no directions, we will take both sides. Now for the directional, it is one-tailed test. So it's either a left-tailed test or a right-tailed test. Okay, it depends upon the HO. So this one, since this is greater than, this is also greater than, so these two are right-tailed tests. Now for these two, they uses less than, so this is left-tailed test. So this is right, this is left, tailed test. Okay, so this is also very important in the hypothesis testing. You must know whether it is a right-tailed test or a left-tailed test or a two-tailed test. And of course, aside from that, the test statistic is also very useful because if you're wrong in choosing your test statistic, then the proceeding steps will be wrong. So we have here, this is a one-tailed test, a left-tailed test. This is left. This one is a right-tailed test. So again, a one-tailed test, and this last one here is a two-tailed test. Now look at this. The shaded region is the critical region, or again, this is the rejection region. Okay, so opposite to that, of course, this unshaded region is the acceptance region. So reject HO, this one accept HO. So null hypothesis. Again, this is reject HO, this is accept HO. Accept HO, these two tails here reject HO because these two are the critical region. Okay. Now, how about this? If you notice, there are values here. We have the Z alpha, we have the negative Z alpha, we have the negative Z alpha over 2, and we have the Z alpha over 2. Now, these values here are called the critical values. So, critical values. So, these values separate the two regions, the acceptance region and the rejection region. I repeat, the critical value separates the acceptance region from the rejection region. So this is the critical value. This is or are the value or values that separate the critical region or the rejection region from the acceptance region. Again, we have the critical region or the rejection region. So this is the basis for our decision. Okay, if the test statistic falls inside this region, then of course we will reject the null hypothesis. Okay, now last we have the p-value. Now the p-value is the smallest level of significance at which the null hypothesis will be rejected based on the information contained in the sample. So aside from computing this test statistic and comparing it to our critical value, so these two will be compared, the test statistic and the test statistic critical value. Aside from doing this, we can also use the p-value. Okay, so later in our discussion for word problems for this one, I will teach you how to compute for the p-value. Now, in deciding using this p-value, we will only compare the p-value and the level of significance or the alpha. If your p-value is less than the alpha, so mas maliit siya sa alpha, then we will reject HO. So if we reject HO, then of course we will accept the alternative hypothesis. Because if you look at this visually, so say for example, we have a left-tailed test. This is now our alpha. Both of them are level of significance. Alpha is also the level of significance. Now, if your p-value is lower or less than alpha, of course, the p-value will be somewhere here, inside the shaded region, somewhere here. So meaning, it falls inside the critical region or the rejection region. Therefore, we will reject HO because it's inside the shaded region. In the same way, if we go to the right side, if it's on the right, then of course, if p-value is lower or less than the alpha, then of course, the p-value is inside this region. Again, this is a critical region or the rejection region. The same thing, we will reject HO. Otherwise, if it is greater than the alpha, then of course, the p-value will be somewhere here on the unshaded region. So the unshaded region is the acceptance region. Therefore, HO is not rejected or HO is accepted if the p-value is greater than alpha.